Okay, I just did chapter 9, energy, power and resistance. My biggest note before I say anything else is this is definitely commonly neglected, because this is the kind of topic where you would have thought, oh no, I definitely know anything, I know everything here. But there were things that I did forget, because, learned them so long ago. Anyway, okay, so first note, when saying that the reason resistance decreases with increasing current is, at the very least, in a semiconductor, is because more electrons are being excited by that temperature and moving into a higher energy level into the conduction band, so that they can increase the number, density, blah blah blah, increase the current. Nothing else on the first three. I think that's all fine. This definition of resistivity is an intrinsic quality of that material which determines how much it resists the flow of electrical current. Keep that one in here. There was one that I answered it as a 6 marker. It's a question about measuring resistivity of the lead of a pencil. Fine, just remember to say that you measure things with a ruler and a micrometer along different directions, and take a mean. Always plotting a graph. I made a mistake on whether or not changing the container for a fluid would change its resistivity, because I forgot to write it. I didn't write it out properly, and I just thought, oh, so something's going to increase by a factor 4, but that's also going to decrease by a factor 4. But I forgot, when you're determining resistivity, one will increase by a factor 4. Talking about area and height in a tube. One will increase by a factor 4, one will decrease by a factor 4, but because they're being divided by each other, it's going to increase by a factor 16 in this case. So you should write those kind of things out, changes in proportionality, to make sure you don't make a mistake like that. Something I hadn't thought about, for when you have a big chunky wire that's lots of little wires, the reason it decreases the resistance so much, you could say because it increases the cross-sectional area, which is what I said, but then also, when you think about it, it's because all of those wires are acting as small resistors in parallel with each other, which is thereby decreasing that resistance. And I think that, could be, a useful little bit of extra depth. I just overcomplicated question 9. PD across the cable length. Remember, power can be dissipated in wires as well, if they're modelled as not having zero density. I hope they don't have zero density, as having zero resistance. I thought that was something else. No, that might have been it. A reminder to Jimmy rig your shoulder questions. Oh, yes. Something that happened to me that maybe has happened to other people, I'm not sure. I was never actually, maybe just no one said it or I didn't take it in. I didn't know what a kilowatt hour was. I thought, oh, we must just be converting it to hours or something, and then I ended up dividing it. What did I do? Did I times it by 60 squared? Kilowatt hour is just kilowatts times the number of hours. It's a measure of energy. It's a bit like the way you measure Hubble constant in different things. The units cancel out, so it becomes a measure of energy in this case, or time in the Hubble constant, I hope. Because you get it down to per second, because it's per meters, it's kilometers squared per parsec. So it's just, to convert kilowatts, let's just simplify this, to convert watts hours to joules, you times it by 60 squared, because you've just times it by the number of hours without times by the number of seconds and minutes. To get to watts to watt hours, it's just wattage times the number of hours. And that's just something we do for some reason. Okay, just take that in. Yeah, I think that's it. Just remember to write all your workings, and hopefully that will prevent you from making some of the silly mathematical mistakes that I did. Yeah, remember conductors, semiconductors, and insulators, about having electrons in the conduction band, ones that can move and traverse, and then having ones in the, what's it called, it's the conduction band, the bear with me, electron energy band for insulators. Valence band, that's what I'm looking for. Valence band to conduction band to increase your density of charge carriers, I's and F. We got